Lesson number 5th, coordinate geometry. Under this lesson, I told you to solve the exercise number 5.1. I hope all of you solve. And the solved examples I told you to copy down in your notebook. If not, today all of you send your homework and complete that solved examples also note down in your notebook. Now we will start the new part of our lesson. That is, let's recall part is there. And this property we know that if we see the figure, we understand that this is the property of three parallel lines and the transversal. Okay, so here transversals authorize property of intercept made by the parallel lines. Intercept made by the parallel lines. So in this figure, here L, M and N, these three are the parallel lines, and P and Q, and P and Q are the transversal. P and Q are the transversals. Okay, and they made the interceptor AB and BC on P and DE and EF on Q. This interceptor made by this parallel lines on this transversal, or transversals made on transversal. So we know that if the three parallel lines are there and it is intercepted by P and Q, these two transversal, then the ratio of AB upon BC equals to DE upon EF. Okay, this property we know, and that's why it is given in the part of let's recall. Let's recall inside it is given. So here it is given, that is AB upon BC means intercept made by the first transversal and intercept made by the second transversal on the same parallel line are equal. Okay, ratios of intercept made by the transversals are equal. And here next property is next it is the division of a segment. Let's learn inside it they give division of a line segment. Here AB is one line segment. Measure of AP is equal to 6. Here it is given. PB equals to 10. PB's measure is 10. And here AP upon PB. AP upon PB is equals to how much it is there? 6 upon 10, because AP's measure is equal to how much? 6, and PB is equals to 10. And when we divide this, 2 3s are and 2 5s are, 3 upon 5 is the AP upon PB's answer. The next point is in other words, it is said that the point P divide the line segment AB in the ratio 3:5. So here this point P is there, it divides the segment AB into 3:5 ratio. Okay, let us see how to find the coordinates of point P on a segment which divide the segment in the following ratio. So here we have to find out the coordinates of P. How to find out? We are going to learn here x and y. These coordinates are there if we taken. So we how to find the coordinate of point P which divide the segment AB into 3:5 ratio. So that we are going to learn now. So here it is section formula. Here it is also, let's learn inside given section formula. If you see here figure, the seg figure P on a seg AB. This is the point P. This only segment is there, above segment. Okay, and here it is P is a point on AB. P is a point on seg AB in XY plane. In X and Y plane. In this inside it is present. Divide seg AB in the ratio of M:(n). M:(n) ratio inside they are dividing. Suppose this is M and this is N. Upside measures they are taken 6 and 10, but here M and N are the values we are taking. M:(n). Assume that the coordinates of point X A is equal to x1 y1 and coordinates of point B is equal to x2 y2. That we have to assume, and the P's coordinates we have to take, that is x and y. Okay, so clear till that. For exam means how it is derived it is given, but for exam the formula only important for this. Draw seg AC. Now we have to draw the perpendiculars from point A, P and point B. So here it is AC, PQ and PD. Now here the coordinates of point C. If you see here, point C, point Q and point D, they are located on x-axis. These points are located on x-axis, and as we know that all, if the points are located on x-axis, their y-coordinate is 0. Their y-coordinate is 0. So here C's coordinate is x1 0, because x-coordinate x1 is same for this. Here x is same and here x2 is same. Okay. Now C's coordinates are x1 0, Q's coordinate as x0 and D's coordinates are x2 0. Okay. Now CQ is equals to distance, as we know that if the points are located on x-axis, that CQ is equal to what will come? X minus x1. X minus x1. And distance of OD, this is a distance formula, x minus x1, and distance of QD, sorry, is equals to x2 minus x. Okay, x2 minus x, and for CO, x minus x. Now as we know that these points are parallel to each other, these lines are parallel to each other because these are the perpendicular drawn on the x-axis and all angles are same, so these two lines are parallel. And same way, that's why if the distance of CQ is x minus x1, sorry, x minus x1, then distance of AP is equals to also x minus x1. Distance of QD is equals to x2 minus x. Same way here also distance is equal to x2 minus x. Okay, because these are the parallel lines, and we seen that in the above, that is the if three parallel lines are there and it is intercepted by the which the and if it is intercepted by a transversal, so here AB is a transversal and OD is a transversal, if we are taking, then the intercept made by the line, okay, on the transverse line, three parallel lines on the transversals are equal, that is AP upon CQ for this is equal to PB upon QD. Okay, and for that that is why this is same. So here, and that ratio is also given to us, AP upon A is equal to, so here AP upon PB, just now I told you that AP upon PB is equal to CQ upon QD. Okay, and its ratio is given MS to N. AP's value we find it here about AP and CQ, just put it here. So AP is equals to how it is there, x minus x1, and PB is equal to x2 minus x, and is equal to how much it is there, MS to N. Afterwards, after doing the cross multiplication not N we have to take here for the multiplication, N into bracket x minus x1, N into bracket x minus x1, and this will come here for the multiplication. So M is into bracket x2 minus x. After doing the multiplication, N into x, nx, N into x1, nx1, M into x2, mx2, M into x, mx. And signs multiplication, so you know that how to do this. At first take xx term together on one side of equation, and mm terms take together, xx, and here x2 and x1. So x common, M plus N is equal to mx2 plus nx1, and this mn upon n here we have to take for the divide. So here if you want to find, now above I told you how it is derived, but important is that if you find the coordinate of x, P's f coordinate, if you have to find out, you have to use this formula, that is x is equal to mx2 plus nx1 upon m plus n. And if you want to find out the y coordinate of this, for this I am speaking, for x coordinate you have to use which formula, mx1 upon nx1, mx2 upon nx1, sorry, mx2 plus nx1 upon m plus n, and if for y you have to use my2 plus ny1 upon mn. And a and b coordinates means x and y coordinates are there, a and b's, that point which is located in on segment AB, which divide the segment into ms to n ratio. For that you have to use this mx2 plus nx1 upon m plus n, my2 plus ny1 upon mn. So this is the formula that we have to use for this. So this is the formula that we have to use when we are going to find the point which lies A, B is segment, suppose, and if it locates anywhere here. Okay, so For that we have to, if we want to find out the coordinate of this point P, we have to use this formula, that is mx2 plus nx1 upon m plus n, and y coordinates my2 plus ny1 upon m plus n. Now we will see if this point is located. Now we see in the segment, that is if it is AB is a segment, and if point P is there, if it locates anywhere, here, anywhere, then how, by using above formula we can find that how to find out its coordinate. But this point P is exactly located in the between, if it is a midpoint of seg AB, then how to find its coordinates, that we will see. So coordinates of midpoint segment. So A is equals to, and A is equal to x1 y1, suppose, B is equal to x2 y2, and P's coordinates here we have to take xy. So this is the segment, point P is located exactly in the middle of the AB, or it is a midpoint. So for that, same formula is there. For finding x, we are using this formula, and for finding y, we are using the formula. Here it is above that, this formula only is for x we have to use this, and y we have to use this part of the formula. Now here, as we know that m and n means ratio is how it is there. Suppose this is a segment, here it is m and here it is n, and m is equal to n because P is the exactly in the middle of the segment. So here mx2 plus nx1 upon mn, that is the formula. Here m and n's value is same, you can replace m with the n or n with the m. So here they replace m with the n with the m. So mx2 plus mx1 upon m plus 1. So m is common upon m plus m. Okay, so m get cancels with m, and x is equal to x2 minus x1 upon 2. Same, if you solve this here, you will get the y1 minus y2 upon 2. So if this point is there, if it locates exactly in the middle, or it is the midpoint formula, this point formula is called as a midpoint formula. And which is the midpoint formula? X2 minus x1, sorry, x1 plus x2 upon 2, and y1 plus y2 upon 2 is the midpoint formula. Okay, and that we have to use for getting the value of point P, which is located in the middle of seg AB. Okay, clear all of you? So today we learn the two formulas. If the point locates anywhere on the seg AB, then we have to use this formula. Okay, and if the point is exactly in the middle, then we use the midpoint formula. P is equal to this formula we have to use. Okay, in previous standard we have shown that a plus b upon 2 is a midpoint of the segment joining 2 points indicating rational number a and b for a number line. So it is about regarding to a number line, and it is same for this only, but instead of taking a and b's value, what we have to take here, x2 and x1 coordinates we have to take. Okay, so first of all we will see the solved example. Here the coordinates of point A is 3, 5, b's coordinates are 7, 9, and Q divide the seg AB into 2:3 ratio. So here it is Q, this is point A, and this is point B. Okay, and 2:3 is the ratio. Just now we seen the formula for finding x1. So here write x1 y1 is equal to 3, 5 because coordinates of A's we have to take. x2 y2 is equal to 7, 9 coordinates of B, and m/n is equal to 2:3. Our x coordinate, by using to find the x coordinate we have to use this formula, mx2 plus nx1 upon m plus n. So put the values here. M is equals to m/n is given 2:3 means m is equals to how much? M is equal to 2 and n is equals to 3. So here m is equal to 2, put x1 is equals to how much? X2 is equal to 7. Here it is given that we have to put it here. N's value is 3, x1 is equals to 3. Okay, and m plus n is equal to 2 plus 3 is equals to 5. When you solve this, you will get the answer 7 2s are 14 and 3 3s are 9, and 14 plus 9 is equal to 23, and 2 plus upon 3 is equal to 5. Same for the y coordinate, put the values here. Okay, so easy it is. So here m's value, you know that m is equal to 2, y2 is equals to, see here y2 is equal to 9 plus n, that is 3, and y1 is equals to 5 upon 2 plus 3, and divided by, when you solve this, 2 9s are 18 and 3 5s are 15, and you solve this, you will get the coordinates of point Q, and the coordinates are 23 by 5 and 33 by 5 are the coordinates. Next, find the coordinates of point P. If P is midpoint of segment, just now we seen the midpoint formula is easier than the above formula. So suppose here figure is drawn for our information, very easy it is. Point A's coordinates are given here, B's coordinates are here, and P's coordinate we have to take as a xy. So here A's coordinates we are taking as a x1, y1, B's coordinate we have to take as a x2, y2, P's coordinates are written. What is our formula? X is equals to x1 plus x2 upon 2. So x1 is equal to minus 4 and x2 is equal to 6. Both addition is minus 4 plus 6 upon 2 we have to do. Plus 6 minus 4, 2 upon 2 is equals to 1. Same way y coordinate we have to find out. Y is equal to y1 plus y2 upon 2. So y1 is equal to 2, y2 is equal to 2, 2 plus 2 is equal to 4, 4 upon 2 is equals to 2. So the coordinates of point P are, and don't forget that we have to write one x coordinate at first and y coordinate at second position in the bracket. If you are writing 2 then your answer is wrong. Okay, so in this way we by using the formula, that is midpoint formula, and how to find the distance between the points, section formula. Today we learn the section formula and midpoint formula and the examples based on it. Okay, so today we will stop here only. The next point, that is the centroid formula, is there, that I am going to teach you in our next lecture, and then we are going to solve the solved examples and then exercise is there maybe. Okay, so today we will stop here only. All of you do the practice and learn these two formulas which I taught you today, and solve the solved examples also note down. Okay, thank you.